In this video, I'm going to look at an application involving a quadratic model. So in particular, we have the quadratic function, which can have this form right here, y equal ax squared plus bx plus c, or the second form over here, y equal a parentheses x minus h quantity squared plus k. For the second form, you have the vertex hk. If it's in this particular form right here, then the formulas on the right would generate the vertex. So typically, parabolas are either going to open upward, and if they do, then the lowest point right here is going to be the vertex, which we'll label it as hk. And the parabola will open upward if the coefficient of the squared term in the examples that I have above, formulas, it's a, is positive. Okay, so let's suppose this represents a cost function. So we produce h units this way, and then this, say, represents the k value, then represents the minimum cost of production. Okay. So in business, we want to minimize the costs and maximize the profit. Okay, so now let's suppose we're looking at a profit function, or it could be revenue function. It opens this way, and in this case, the a value would be negative, and the vertex would be the highest point of the graph. We will label that as hk. HK. Okay, so that means if we sell H units, then the profit we get is K. Okay, so in this case, because the graph opens upward, the highest or largest value the function can have is K. So we say K is the maximum profit. And it occurs when we sell, say, H units. Okay, so if the model represents a quadratic function, the graph will be a parabola. So it's very easy to maximize or minimize because all you're going to do is find the vertex. Okay, but sometimes you're going to have, say, a model. I go like that, maybe like this, and maybe like this, and then comes down. Okay, so it reaches two, what we call relative maximum values. So we have one right here, and one over here. So obviously, we want the largest value. So in this case, we're concerned, say, with this particular animal right here. Okay. So the formulas that I have here for a parabola are not going to work on this because this is not a quadratic function. Okay. So the method I'm going to give you will work for these types of curves, and that's using the graphing calculator. Okay. Let's look at an example. Okay. Now in this particular case, this is a quadratic function. So the method here will work. You can find the vertex using the first formula, say, since it's in this particular form, and you can solve this problem, okay? But if it's not a parabola, this is not going to work, okay? So using the calculator, we're going to solve this problem. So let's look at the example. It says the function f of x is equal to, okay, there you have it, models the number of individuals whose age x is x and engage in hunting activities. So x represents the age, and then the f of x represents the number of hunting activities. So this one says, what is the age at which there are the most hunters? Okay, so basically it's asking you to find the vertex. So you can generate the H component and the K component, and you know what is going to be the maximum. So notice this has a negative coefficient here for the square term. So we anticipate the graph is going to open this way, open down. Okay. So to solve the problem, all we need is this vertex right here. Okay. So let's look at the calculator. Okay, so what we're going to do is we're going to graph it. Okay, so here I have it. I have the function graphed. You don't see the rest of it, but it's over here. Okay. So there's the whole thing. Okay. Now, if you just hit graph on this, you might just get a line or something that doesn't make sense. We know what a parabola looks like, and we expect this parabola to open down because the coefficient of the squared term is negative. So because we have these large numbers here, if you hit graph, you might not get what you want. Okay, so what you want to do is go to zoom, and sometimes you might want to try zoom fit. It'll try to put the whole graph or the main part of the graph in the main screen here. In this particular case, the numbers are so large it didn't work. Generally, the main one to use is Z standard, but that goes on the X value. The window is from -10 to 10, and on the Y axis is from -10 to 10 also. Okay, so what you want to do is go to your window, and what I did is I let I'm only interested in positive values. Okay, so I said, well, let's run the X from 0 to 50. Okay, and again, I'm only interested in positive values for the Y, so I'm going to run it from 0 to 4,000. Okay, and you can play around with this. And then I hit graph. And as long as you get the main shape of the parabola, you can see here we have it. Okay, so right there at the top, the answer is going to come from that vertex. Okay, so what we're going to do here is hit the second key here, and we're accessing the calculate menu here. We hit the trace key here, and in this particular case, we're actually looking for a maximum because the parabola opens downward. So I hit 4. Okay, so now it says left bound. So the way this works is you go up to hit the arrow here, just go up and get kind of close to the vertex on the left side, and then hit enter. Okay, and then we want it right bound, so then we go past the vertex. Okay, so just keep going here, go up all the way to the top, and you don't have to go that far. You can go further than I did. Again, it's still going to work as long as you're to the left and to the right. So okay, there I'm pretty sure I'm past it. You can see I passed the vertex. So I hit enter again, and then it wants you to guess. Okay, you can guess or you can just hit enter. Okay, so I just hit enter, and it computes it out. Okay, so you can see then 37.3 maximum value is X is equal to 37.36 something, so I just run that after 37.4. And remember, the X represents years. The X represents the number of years, and then the Y represents the number of hunters. So that's 3784, 3,784. If you run it out to the nearest whole numbers, 3784. Okay. Now we can go over here. Say, what is the age at which there are the most hunters? Okay. That's 37.4 years. Okay. So this generated the X value. And then approximately how many hunters are there at this age? So approximately how many hunters are this age? and according to the model, it's 3784, 3,784. Okay, and then it asked, are the number of hunters increasing or decreasing for individuals who are between 40 and 45? Okay, so just a rough sketch of the graph. Okay, on the positive side, so I have to draw it. It goes something like this. So the vertex here is 37.4. And that's in years. That's the x value. And the y value is 3784, 3,784. Okay, so right here is 37.4 years. Okay. And it wants to know, is the number of hunters increasing or decreasing from 40 to 45? Well, we know this, you can see from the curve, 40 and 45 are going to be over here somewhere. So you can see the graph is falling, and the vertical distance represents the number of hunters. Okay, so at 40, say we're here, and at 45 we're over here. So you can see it is decreasing. So again, getting back to this, the age for part A, part 1 is 37.4. Number of how many hunters are this age? 3,784. And of course, the answer to part B from the graph you can see is decreasing. Okay. So like I said, if the model is a quadratic, you don't have to use a calculator. You can easily find the vertex using either one of these formulas. If it's in the first form, you use this setup over here. If it's in the second form, this way, which is fairly easy if it's in this form, vertex HK here. If it's not a quadratic function, okay, say it's fourth degree or cubic or something, then you can use the calculator. And again, keep in mind that depending on what the values are, if you have real large values, you might have to change the window to get a graph that allows you to solve the problem. Okay, thanks for watching. We'll see you in the next video.